Hello, welcome to day 7. So what we're going to do today is learn how to solve any quadratic equation using the quadratic formula. So let's review our learning target. So on day 6, learning target 5, it says I can use a discriminant to determine the number and type of solutions. So we learned how to do that, and that's always going to be our first step when solving the quadratic formula, is to calculate the discriminant off to the side. And then we're going to learn how we can use to solve a quadratic equation. Now, what's really important to remember is the quadratic formula always works. However, we don't always use it because it's not always efficient. It's lengthy. It takes time, as you'll see in these next examples. So what I'm going to do for these notes is I'm going to do the first 2 examples from day 7 notes in detail. That's going to be one video. The next video, I'm going to ask you to practice the remaining problems, and then I want you to check your answers, and I'm going to talk through my work. Okay? So next, let's talk about the quadratic formula. Now, if we were together, you would be expected to memorize, whoops, didn't mean to do that. You would be expected to memorize this formula. So you're going to need to do your very best to do that. And the reason is because you're going to be expected to know it for further math classes along with any standardized tests. So it's just as important as if I asked you the slope formula or slope-intercept form or point-slope form. These are things we'll have to know. So as a reminder, and you should have practiced this already, the quadratic formula is x equals opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And as a reminder, this b squared minus 4ac has a special name. I always do that. It is the discriminant. And so that is what we are always going to solve for first. Okay, so the directions will look something like this. Solve the following quadratic equation using the quadratic formula. Show both the exact answer, which is what our final answer will be, and its decimal form. So what I'll do is I'll double check on Desmos, making sure I did it correct. So without further ado, we're going to start problem 1. So I'm going to go in detail. We can cross this example out. We'll see it on the next slide. So the first thing I need to do is define what a, b, and c represent. So remember, standard form is ax squared plus bx plus c equals 0. So a equals 3, b equals 17, and c equals 10. So step 1, always and forever, is we're going to calculate the discriminant. So, as we said, the discriminant is b squared minus 4ac. So, we're going to take 17 squared minus 4 times a times c. We're going to type it into our calculator exactly as we see it there, and let's see what we get. Okay, I got a discriminant of 169, and that's pretty awesome because it's positive, which tells me I have 2 real solutions, so I should continue on with my problem. I also know it's a perfect square, so that's great. And so let's continue. Next step is we're going to plug everything into the formula. Okay, so I have x equals opposite of b plus or minus the square root. Now, I already know the discriminant, right? My b squared minus 4ac is 169 all over 2a. And some students like, so 2 times 3, you could just write 6 if you prefer. That's fine to do, okay? Next up, what we're going to do is, I'm going to go over here. Well, I'll go down. Is we're going to simplify the radical. And in this case, as I said, square root of 169 is a perfect square. It's just 13. So we're going to replace that and simplify. So now I'm just going to say simplify. So let's go back to what I know. I know x equals opposite of b plus or minus. Now here's what we're going to fill in our radical. So in this case, it simplifies just to 13. all over 2a, which was 6. Okay, so now, because there's no radical, right, it undoes itself, we can simplify and get our two solutions. And so I'll say list two solutions. So how do I get those? Here's what we're going to do. So to get our two solutions, we're going to take negative 17 plus 13 over 6 and simplify. And we're going to take negative 17 minus 13 over 6 and simplify. So again, you may be asking, where does that simplifying come from? Or where does that plus or minus? Remember, plus or minus is going to give us our two solutions. So we're going to break it up. And what am I going to do here? So negative 17, so we're going to get negative 4 6, which is negative 2/3. And then here we have negative 30 over 6, which is negative 5. So my two solutions are negative 2/3 and negative 2/3. Yeah, and negative 5. So what this tells me, when I look at my solutions, they're rational. This tells me that I could have actually factored and gotten my roots. But if you look at this original problem of 3x squared plus 17x plus 10, when a leading coefficient's 3, I didn't really want to start guessing and checking. And so that's why I went to the quadratic formula right away. Now, I'm going to graph this on Desmos really quick and insert an image so we can double check that our solutions are correct. So I just double checked on Desmos and I got the same solution. Now keep in mind, again, for graphing, we would never write negative 0.667 as a final solution because that's not exact. The exact answer is negative 2/3, comma, negative 5. So when you're solving the quadratic formula, you're always going to follow these 5 steps. I understand that if you watch different resources or watch different videos, they may take you through different ones, but I really think this is the best way to go, and so I want you to always use these 5 steps. So make sure they're written down in your notes. So what I did is I listed our 5 steps that we're going to take. So I would recommend pausing the video and copying this down, and then we'll go through the 5 steps. So unpause, we'll pause, write everything down, and then unpause when you're ready to move on. Okay, so here we go. So we're going to calculate the discriminant. So again, I know that A equals 4, B equals 12, and C equals 9. So remember, the discriminant is B squared minus 4AC. So we're going to take 12 squared minus 4 times 9 and calculate that. And when I entered that in my calculator, I got 0. Ooh, special case of a discriminant. So remember, when our discriminant equals 0, we're going to have one real solution, meaning it's going to be a double root. Okay, so let's find that. So here we go. Plug into formula. X equals opposite of b plus or minus the square root of 0 all over 2a. Okay, so simplifying the radical, that's just 0, right? So we don't have to do anything there. So I'm going to skip that step, and we're going to get x equals negative 12 over 8. Okay, now we know it's a double root, and so when I say list two solutions, that means we're going to just list them twice. So I'm going to reduce the radical. Okay, because again, going back to this discriminant, this tells us a lot. I know that my vertex is going to bounce, right? Because it's one real solution, a double root. So in terms of simplifying, it's fairly straightforward. What that also means is that I could actually have factored this. This would have factored to 2x plus 3 times 2x plus 3. But again, we're practicing using the quadratic formula. So I'm going to do one more example in detail with us. So I know I said 2 at the beginning, but bear with me. So we're going to do one more example in detail. Now what I notice on number 3 is that it doesn't equal 0. So the first thing I need to do is I need to rewrite my quadratic using inverse operations so that it equals 0. So at the top, I know A equals 3, B equals negative 9, and C equals positive 5, right? Because I have to use inverse operations and move it to the left side. So first thing we always do is calculate the discriminant. B squared minus 4AC. shouldn't do an equals, we're going to do an arrow. So B is -9. Make sure you put that in parentheses. It makes a difference. -4 times A times C. I got a discriminant of 21. It's positive, which tells me I'm going to have 2 real solutions. I need to keep going. So I'm going to plug in my values. X equals opposite of B. So remember, B is -9, so opposite is +9. Plus or minus the square root of 21 all over 2A. So simplify radical. Can I simplify square root of 21? No, right? There's no perfect squares that go into it. So we're going to go down here. X equals 9 plus or minus the square root of 21 over 6. So when I say list 2 solutions, we're really done. You could go one step further if you wanted and write x equals 9 plus square root of 21 all over 6. And 9 minus square root of 21 all over 6. The one thing to keep in mind is we're always going to look at 3 different spots. 9, the coefficient right there, and 6, and ask ourselves, can they simplify? And in this case, they can't, but I'm just going to give you an example where they can. So this is not this problem. It's a different problem, so I'm just going to go over here. If I had the final answer, x equals 3 plus or minus 6 root 2 all over 3, right? And I'm looking at these 3 spots, 1, 2, 3. Those all do reduce. I can all divide them by 3. So I could do 1, 2, 1. And so my final answer would be x equals 1 plus or minus 2 root 2 all over 1. So what I want you to do is I want you to try the remaining problems. I'm going to make another video with the answer key for you to check, and I will highlight common errors or things to catch on the remaining problems. So from now, I want you to try the remaining problems in the notes and then watch the video to check your answers when you're done.